Hey folks, welcome to Data Engineering Minds, and once again thanks for checking my channel, and I hope you're all having a good day so far. So today in our session I'm going to show you how to launch a Postgres database server inside a Docker container, and then how to write a simple Python application that is going to insert some records into this Postgres database. This Python application is also going to run in a separate Docker container. So the whole communication between the Postgres and the Python application is going to happen purely via the Docker. And also for our session today, I'm going to seek the help of ChatGPT to make my life easier. So let's get straight into the topic. So first, let me create a folder called Postgres_Python. So I'm going to put all our code components today inside this folder. And then for launching the Docker containers, I'm going to launch them via Docker Compose. So first, let me create a file called docker compose.yaml. So at first, we are going to launch a Postgres database. So for this, I'm going to seek the help of ChatGPT. So I've asked ChatGPT to provide some example for Docker Compose for the Postgres database. And as you could see, ChatGPT has provided a example Docker Compose file. It also specifies the details for each part of the code. And it also provides an example for launching the Docker container for Postgres. So let me copy this example Docker Compose file and paste it into our file. So the first thing is version. I'm always going to stick with the third version because I found it to be a very stable version. And then we have services. So the services mention all the different services that we are going to launch via Docker containers like Postgres, Python, and whatever it is. So first one is Postgres. So let me call the service name as Postgres. And then the image. So let us stick to the latest version of the Postgres image. And then let us leave the restart as always. And then we have the environmental variables for the user, password, and database. So let me call my username as Postgres and the password also as Postgres. And then we have the Postgres database. So for our session today, I'm going to create a new database. Let me call that as OLTP_DB. And then we have volumes. So volumes specify the Postgres storage path. So I'm going to stick with this default path, and for this session, I'm not going to mount any volumes for the storage. So I'm just going to remove it. And then we have the port. So for the port, let us stick to the default port 5432. So this means if you want to access the Postgres Docker locally, you also need to access it via the port 5432. And then once you finish launching this Postgres inside a Docker container, and then when you write a Python application inside another Docker container, and if you want both these Docker containers to communicate, then both these Docker containers has to be part of the same network. So for this, we have to create a network. So I'm going to create a networks, and I'm going to call the network as DEM. Okay. And then you have to specify which network this Postgres container will be running. So let me use the same DEM network. Fine. Now, I also want a table to be created inside this Postgres database when I launch a Docker container. And I'm going to insert some records into that table. So if you want some SQL scripts to be executed when you launch a Postgres, then they need to be part of the Docker initialization script for Postgres. So for that, I'm just going to first create a SQL file called init.sql. And inside this init.sql, I'm going to first create a schema called OLTP. And then I'm also going to create a table. Create table OLTP.user_transactions. So I'm just going to capture all the different transactions made by different users. So as you could see, my GitHub Copilot is already coming with some recommendations. So I'm just going to use it. I want to have user ID, and then I want to have the amount. So I'm just going to have these two variables. And then I also want to have another variable called created@. And for this created@, I'm just going to create a timestamp. I'm going to create this variable as a timestamp value. And I also want to provide some default for this. So let me first call this timestamp as without time zone. And then I want to have a default. So the default is going to be now at times zone UTC. You can use either now or you can also use current underscore timestamp. And this timestamp cannot be null. So I'm just going to call it as not null. So when I'm launching this Postgres Docker container, I want these two things to be created already, like the schema OLTP and then a table user underscore transactions inside this schema. So for this, so now you created this init.sql, and then I am now going to mount this SQL file as a volume inside this Docker container. So as you could see, my GitHub Copilot already provided a recommendation for it. So our SQL file is going to be called as init.sql. And then this init.sql has to be mounted into this path, docker entry point initdb /init.sql. So now when you launch this Postgres Docker container, all the scripts that you specified inside this SQL file, that is the schema and the table, those two scripts will already be executed, and then by the time you access the Postgres Docker, they will be available. So that's the idea behind putting those scripts inside this init.sql file and then making this init.sql file, mounting this init.sql file as part of the Docker entry point. So now we have the code for the Postgres Docker ready. So let us launch this Docker container. Let me use the terminal just to make the display very clear. So we are going to launch the Docker via the docker compose command. So docker compose, and then we are going to use the docker compose by means of a file, right? So let me specify this file command and then our actual docker compose file. And then for launching the Docker container in detached mode, we are going to use the command up and -d. So you could see that the image is now being pulled. The Postgres image. So the image is completely pulled and then the container is also started. So let's check it. So if you type like docker ps, you can see this Postgres Docker container is now available, and then you can access this Postgres Docker container by means of localhost and then port 5432. Now I want to see whether all these schema and tables are created. So let us try to check this thing visually. So for this purpose, I'm just going to use pgAdmin, and we can also create this pgAdmin as a separate Docker container. So let me go to the ChatGPT once again and then ask for help. So now I've asked ChatGPT to provide a Docker compose for pgAdmin as well. So as you could see, ChatGPT has now provided an example for launching pgAdmin inside a separate Docker container. So I'm just going to copy this pgAdmin example and then paste it inside our Docker compose file. So now we have pgAdmin as a new service inside our Docker compose. I'm just going to stick with the latest version of the pgAdmin, and then let it leave. Let us leave the restart as it is, and then we have the environmental variables for the username and password. The email and the password. So let me call this email as admin@admin.com, and then we have this password. I'm just going to call it as admin as well, and then the port. So pgAdmin is going to run inside a port called 80 inside the Docker, and if you want to access via the localhost, you can access via 8080. Since I have the port in 5000, so I'm just going to stick with something 5000. So let me call it as 5000. And then this pgAdmin has to be launched only after the Postgres is launched, right? So for example, if you're going to run this Docker compose all together for all the services at once, then pgAdmin has to be dependent on Postgres. So only when we finish launching the Postgres, pgAdmin has to be launched. So that's why we need to specify depends on which service. So we called our Postgres service as Postgres. So let me call it as Postgres. And then for this pgAdmin service, to be able to communicate to the Postgres, they need to be part of the same network, that is DEM. So just like how you specified the networks here, go to this pgAdmin and also specify the network. Perfect. Now let's launch this Docker container for the pgAdmin. So I'm just going to run the same command, that is the docker compose, and it's now going to launch the pgAdmin because Postgres is already done. So now it's pulling the image for the pgAdmin. So as you could see, the image is pulled, and then it also launched this pgAdmin container. So if you type docker ps, now you can see two Docker containers. One is for the Postgres and the other one is for the pgAdmin that we launched just now. Now let's try to access this pgAdmin and then check our Postgres database. So pgAdmin you can access via the localhost and on the port 5000. So just go to your browser and type localhost 5000. So you can see now the pgAdmin has launched, and we gave the email as admin@admin.com. Let me put this admin@admin.com, and then the password is also admin. So now we have the pgAdmin on our localhost. So first we need to create a server for checking our Postgres database. So let me call this server as OLTP server, and then the connection. So inside the connection, we have to provide the connection details for our Postgres database. So as I already said, now we have two services, Postgres and pgAdmin, and both these services are part of the same network, that is DEM. So you have specified the network DEM inside the Postgres and also inside the pgAdmin. So pgAdmin now can access this Postgres service by means of the Postgres name, because both of them are part of the same network. So for the host, we have to specify Postgres and then the maintenance database. So we created a new database called OLTP_DB. We are going to access that database now. So I'm just going to put that database, and the port is going to be 5432 because Postgres is also running on the port 5432 inside the Docker container. So we have to specify the port 5432 and then the username. So username for our Postgres database is going to be called Postgres, and we also use the same name for password. So now you see our Postgres database is now connected, and if you go inside the database, you can see this OLTP database also available. Now we also want to check whether these scripts like the schema and the table is available or not. So just go inside the Postgres database and then go inside the schema, and inside the schema you can see the schema OLTP which we created. And then if you go inside this schema, you can also see the table user_transactions that we created. So we have three columns: user ID, amount, and created at. So that's how, like if you want to create this some tables or schema, whatever it is, when you launch a Postgres database without doing it manually, then you have to specify some file like this, and then you have to mount this as a volume inside the Docker entry point folder of the Postgres container. So now we checked our Postgres database via the pgAdmin. Now let's start writing our Python application for inserting records into the Postgres table. So let me create a file called postgres.py. And for our session today, I'm going to use SQL Alchemy for connecting to the Postgres, because SQL Alchemy keeps most of the things abstracted, and hence it is very easy for using to connect to the Postgres. So for this, I'm just going to go to the ChatGPT once again and ask for some help. So I've asked ChatGPT, like that I'm going to write a Python application using SQL Alchemy for inserting records into the Postgres table. So you could see now the ChatGPT has provided some examples using SQL Alchemy for inserting into the Postgres table. So I'm just going to make the code very simple. So I'm just going to copy only certain sections of this code that I need. So first thing is create engine, because we need to first create an engine for connecting to the Postgres database. So for this, I'm just going to copy this part, that is from SQL Alchemy import create engine. And for installing SQL Alchemy, you need to have a requirements file. So let me create this requirement file like requirements.txt. And inside the text, requirements.txt, we need to specify all the Python libraries that we need to have for running our script. So first one is SQL Alchemy, but SQL Alchemy is dependent on 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐶𝐂𝐒𝐂𝐑𝐈𝐏 because SQL Alchemy is based on an abstraction on the top of 𝐃𝐄𝐒𝐂𝐑𝐈𝐏. So if you want to have SQL Alchemy, then you also need to install 𝐃𝐄𝐒𝐂𝐑𝐈𝐏. So we have now 𝐃𝐄𝐒𝐂𝐑𝐈𝐏 and SQL Alchemy inside our requirements file. So first part is, as I said, we need to create this engine. So I'm just going to create this engine. Let me go here and copy this part for creating the engine. So I'll put this inside a separate function. So get db engine, and inside this function I'm just going to copy this part. I'm just going to return this engine part. Then you need to specify the username, password, the host name, as well as the database details for your Postgres database. So let me do it in a nicer way. So first I'm just going to pass everything like in terms of parameters. So if you want to do like this, then you need to do like format, and inside format we need to specify the values in order. So first thing is username. So username is Postgres, and the second thing is the password, which is also Postgres in our case, and the third thing is this one is the host name. So first I'm going to run this Python script locally. So for accessing the Postgres database, the Postgres database container locally, we need to use localhost and on port 5432. And then finally the database name for us is like OLTP_database. So once this is done, then we have the engine ready. So we also specified all the details for the Postgres database as we mentioned in the Docker Compose file. As I mentioned before, first I'm going to run this Python script locally, and that's the reason for the host details of the Postgres. I mentioned it as localhost instead of the Postgres service name, because first we are going to run this script locally, and the Postgres Docker container is reachable locally by means of the localhost and on the port 5432. So first let us try to call this function and get the connection to the database. So I'm going to create a variable called db engine, and I'm going to call this function. And once you get the Postgres details, you need to call the function called connect for connecting to the Postgres database. So please remember, the Postgres database might take some time to get ready. So if you are running the Postgres database and this Python script, all part of the same Docker Compose file, and if the Postgres database is not yet ready, then this Python script might fail when it tries to connect to the Postgres database. So you need to normally implement a retry mechanism whenever you write a Python script for connecting to any database for that matter. So let us try to implement a retry mechanism. So I'm just going to call a while loop, an indefinite while loop. And in this indefinite while loop, I'm just going to call this, use this try and exception method. You could see that my Copilot has already provided some suggestions. So first thing is I'm just going to call as db engine is equal to get db engine connect, and then I'm just going to use a if loop. So if the engine is ready, then I'm going to break this while loop. So if the engine is not ready, then this part will fail. Actually, this part will fail, and hence you need to write an exception for that. So inside the exception, I'm just going to write a print statement. So the print statement looks like this. So error in connecting to the database because of this exception. So we now implemented a retry mechanism whenever we are trying to connect to the database. So now let's start inserting some records into the Postgres table that we created already. So for this, I'm going to use a library called faker for creating some fake records for inserting into the table. So we need to have a library called faker, and the language that we are going to use is English. So for the faker library, it's important that you specify which language you want to use for creating fake data. Of course, we are not going to create any variables, like characters or strings here. We are just going to insert two records, which is user ID and then amount. Both are integer, but still it's better to specify this variable here. And then inside the requirements file, we are going to use this library, right? So we need to specify this faker library as well. And then inside the import statement, you need to import this library as well. So from faker, import this class called faker. So first I'm going to start with inserting 10 records. So for that I'm going to write a for loop for I in range of 10. So let me put some print statement like which record I'm inserting. So inserting record number 1. So I starts with 0, so that's why we need to specify I plus 1. And then we have two variables that we need to insert. The first one is user ID and the second one is amount. Both are integer variables. So I'm just going to create user ID, a variable called user ID, and for this I'm going to create a fake ID. So let me call it as random underscore int, minimum is equal to 1, maximum 200. Let me call it as 200. So I'm going to capture user transaction details into this table. The user IDs should always be between 1 and 200. And then for the amount, I'm going to use the same thing, but instead of user ID, it's going to be amount. And then we are going to create a fake data. So let the amount start between 100 and then 10,000, for example. And then we need to write the insert statement for inserting into the table. So for this, I'm going to create an insert query. So my Copilot already provided some suggestions here. So our table name is oltp.user_transactions, and then we have two variables, user ID and amount, and then the value is user ID and then amount. So we also have one more variable called created@, but we specified the default as current timestamp. So whenever you're inserting some records into this table, this value will be created by default. So we need, we need not handle this thing explicitly. So now I have the insert query ready. So I need to use this variable called db engine, then execute, and then insert query. So for inserting the records via SQL Alchemy, first you need to create this db engine, and then you need to use this db engine and provide the insert statement. And also please note here that this SQL Alchemy is using a function called text for for handling this insert query. So we also need to import this text. So from SQL Alchemy, import text. So now whenever you're executing the insert query by means of db engine, also please specify auto commit is equal to true. So you need not handle this commit separately. So once this is done, we are also going to write a print statement that this insert has been completed. Completed inserting record number I plus 1. So after inserting the 10 records, the for loop is going to exit, and once it is done, we are just going to close the connection. So for this, we need to specify dbengine.close. So with this, we now finished writing this Python script for inserting records into the table. So to summarize, first we tried to install SQL Alchemy, and then we created an engine statement. We tried to create an engine for the Postgres database. And then we also implemented a retry mechanism for connecting to the Postgres database. So whenever there is a problem connecting to the Postgres database, this Python script is going to keep on retry until it gets the connection to the database. And then we tried to insert records for two variables, user ID and amount. And for creating records for these variables, we used the library called faker and created some fake integers. So first, as I said before, we are going to call this Python script and insert into the Postgres database locally. So that's why we specified localhost. So first we need to install all these libraries that we mentioned inside the requirements file. So for my demonstration today, I have used a virtual environment. However, I have not specified how to install this virtual environment and all those details in detail. You can check my GitHub repository for how to install this virtual environment and how to create a virtual environment for running your Python script. So first we need to install all these requirements. So for this we need to type pip3 install r and then pass the requirements file. So you could see that requirements file is now installing 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐶2 SQL Alchemy. So we are now done with the installation of all the three libraries that we specified here, like 𝐃𝐄𝐒𝐂𝐑𝐈𝐏𝐶2 SQL Alchemy and Faker. So now we can start running our Postgres, like the Python script. So I'm just going to call Python 3, our Postgres script. So we now have an error called fake is not defined. Okay, I need to specify faker because I defined the variable name as faker. So you could see now we installed 10, we inserted 10 records into the table. So let us go back to the pgAdmin and then check this table. So I'm going to execute a select statement, select star from oltp dot user underscore transactions. So let me execute it. Oh, sorry, select star from. So now you could see these 10 records have been inserted. So we are now done with writing a simple Python script for connecting to the Postgres database and inserting records into the Postgres table by using the library SQL Alchemy. Now let me demonstrate how this retry mechanism works. So for this I'm going to kill the Postgres Docker container. So my Postgres Docker container is running here. So I'm just going to kill this Docker container. So docker remove f. So I'm just going to remove this Docker container. So let me try to run this Python script once again. So now you can see that the script is, the Python is not able to find a connection for the Postgres database, and hence it's keep on retrying. So that's what is happening. So you can see that our print statement is visible here, like error in while connecting to the database. So you can see like error in while connecting to the database because it is saying that connection has been refused because the Postgres database is not available anymore. So it's going to keep on retrying. So that's why it's very important whenever you try to write a Python script for connecting to any database for that matter, it's always important that you implement a retry mechanism like this. So I'm just going to kill this Python script now, and then I'm going to restart the Postgres database. So for this, you can just use the docker compose command once again. So it's just going to create this Postgres database once again. So now what I'm going to do is I'm just going to run this Python script inside a Docker container because so far we have been running this locally. So if you want to run this Python script inside the Docker container, then for the Postgres host, you need to specify the service name that you used inside your Docker compose. Okay, so we are just going to use the service name called Postgres because the Postgres Docker container's service name is called as Postgres. So I just used the same name here. Now we are going to start writing a Docker file for creating image for this Python script. So for this, I'm just going to go to the ChatGPT one more time and I'm going to ask some help from the ChatGPT. So I have asked the ChatGPT to provide a Docker file example for the Postgres application. So you could see that the ChatGPT has provided a very detailed example for running, for creating a Docker image for your Python application. I'm just going to copy this code now and I'm going to create a file called docker file underscore app because I'm going to call our Python script as app. And then inside this Docker file, I'm going to paste this example. So we don't need all these things. We are going to keep only the things that is necessary now for us to run our Python script. So for the Python version, we can use either 3.6 or 3.9. I'm going to stick with 3.6 for now. And then whenever you're writing a Docker file, it's always useful to run an update on the Docker container. So for this, I'm just going to run a command called apt get update, and then we have to set the working directory, and our working directory is going to be postgres_python. So I'm just going to call this working directory here, and then we need to copy all the contents of this Postgres Python into our Docker container, right? So for this, we need to execute a statement before setting the working directory, which is copy dot and then Postgres_Python. And once this is done, then we have to install our requirements file. So for installing our requirement file, we can just run the statement, which is pip install requirements.txt. We don't have to copy the requirements file because we already copied the entire contents into the entire contents of Postgres Python into our root directory, which means requirements would also be copied. So we can just remove this line. So once the installation is done, we can then run the Python script. So we don't really need all these statements, and we are not going to expose our Python script via any port. So all these things are not needed. So as I said, we are not going to expose anything. So next step would be like to run this Python script. So we're going to call this Python, and then our Python script name is postgres.py. So first we try to mention this Python version, and then we try to do an apt get update just to make sure that our container is up to date. And then we copy the contents of the Postgres Python into the root directory, and then this Postgres Python is going to be like the working directory. And then we installed all the requirements, that is 𝐃𝐄𝐒𝐂𝐑𝐈𝐏, SQL Alchemy, and 𝐹𝐴. And then finally we are going to call our Python script. So now we have the Docker file ready, but then we need to put this Docker file inside our Docker compose file, where we already have the Postgres as well as pgAdmin. So we need to add a new entry here. So for that, I'm going to go to the ChatGPT one more time and ask for some help. So I've asked ChatGPT to provide a Docker Compose example for launching this container using the using the Docker file that we just wrote. So you could see that ChatGPT provided an example for putting this Docker file inside the Docker Compose. I'm just going to copy this example as it is, and then inside our Docker Compose file, I'm just going to add a new entry. So we are going to call our Python script as app, and then we are going to build the image. So for this, we need to specify the context. So it's going to be inside the same directory as Postgres Python. So we can just put a dot here. We don't have to provide any explicit path. And then our Docker file is called as dockerfile_app. And we don't really need any port because we are not exposing our Python script by means of any port or host. So we can just remove that, and at the same time we can also remove all those environmental things, but we need a volume, and then inside the volume we are just going to put like Postgres_Python. So the reason why I mentioned a volume here is because whenever you are making changes to any requirements or Postgres py script, you don't have to rebuild the image. You can just do a Docker compose, and then everything inside the volume that is mentioned will be mounted into this path automatically. So that's the reason it's very important to specify the volume. And then our Python script also depends on this Postgres database, because only when the Postgres database is created, we can create the Python app, just to be on the safe side. So that's why we need to mention this depends on, and then we can mention the service name for the Postgres, which is Postgres. And then this Python app need to be in the same network of Postgres, so that it can call this Postgres database or connect to this Postgres database by means of using the service name, that is Postgres. So that's the reason we also need to mention the networks, just like how we did for Postgres and pgAdmin before. So we mentioned the networks as well. And then for the Docker container, we also specify a restart mechanism. So I mentioned it as unless stopped. I mean, like when the Docker container will be restarting whenever it stops. So that's the idea behind putting restart as unless stopped. So now we specified the Docker compose for our Python script. So we try to first create a Docker file for building the image and then put this Docker file inside this Docker compose file. And then we also specified the volumes and then depends on, and also we specified the networks. So now we can start running our Docker compose file. And please remember, we also changed the local host, the Postgres host as Postgres. Previously we had localhost, but now we are doing all the connections via Docker. So that's the reason I mentioned the host name as the service name of the Postgres, which is Postgres. So let me run this Docker compose once again. So it's building the image for our Python script. So now our Docker container for the Python script has started. So let us check it. If you type docker ps, so you can see this Python script has started and now it's restarting because now we have like a Docker container for the Python script. When we launch the Docker container, it's going to insert these 10 records and then it's going to finish. It's going to stop. Since we specified the retry mechanism for our Python Docker container as unless stop, it's going to restart whenever the Python script gets executed. Okay, so it's going to insert 10 records, restart, insert 10 records again, once again restart, and that's how the process goes on. So let's check whether we have inserted the 10 records or not. So I'm just going to execute a count. So you can see now over 100 records are inserted. So as I said, it's going to insert 10 records every time, and then the container is going to stop, and then it's going to restart again, and then insert again 10 records. So now you can see that 10 more records are inserted. So in case if you don't want this, like this way of doing, like Docker container starts, it inserts 10 records, then it stops, then it restarts again, and then again it inserts 10 records. If you don't want this kind of thing, then what you can do is like you can just go to your Python script, and then instead of for, you can just use an indefinite while loop. So in this way, you are going to keep on inserting the records indefinitely. So the Docker is not going to restart every time. So I've replaced this for loop by means of while, and then I'm going to declare a variable called I is equal to 0. And then after inserting every record, I is going to be incremented just to capture like how many records are inserted. I plus 1. So now we have replaced the for by means of indefinite while loop. So we just need to do a Docker compose one more time. But before that, just to be on the safe side, I'm just going to kill this Python Docker container. Okay, so let me rerun the Docker compose. So now it has started the Python app one more time. So let me check this one. So our Python app has started, but now you cannot see the restart anymore because we replaced the for loop by means of indefinite while loop. This means this script is not going to end at all. So let's go and check the Postgres records. So you can see now the records are keep on being inserted because this script is running indefinitely, right? It's not going to stop. So that's why the count is keep on inserting. So this is one way of doing the things in a like in a smart way. So in case now if you want to view the logs of your Python script by means of Docker logs, for example, so we can just like replace all these print statements by means of logging. These print statements by means of logging. Yeah. So I'm going to seek the help of ChatGPT one last time for logging. So I've asked ChatGPT to provide an example for logging at info and warning level. So this means whenever there is a warning like error in connecting to the database, I want to display the log as a warning. And then for the normal print statements like this, I want to display as a logging info. So that's why I've asked ChatGPT to provide the logging at info and warning level. So let us see what it provides. So you can now see ChatGPT provide an example, basic example for implementing logging. So we need to set the logging level always at info to capture different kinds of logs like warning, errors, whatever it is. Yeah. So I'm just going to copy this import statement. I mean, we just need to import the logging, right? So just import logging, and then I'm just going to copy this logging level statement. And then I'm just going to create a variable called logger, and I'm just going to like use this variable name for writing the logging details. So now instead of the print statement, we can just use logging. So for this is going to be a warning, right? Whenever we are failing to connect to the database, this is going to be a warning. So I'm just going to replace it as logger.warning, and then for the normal print statement, we can just call as logger.info. So now we replaced the print statements by means of logging. So for the effect to take place, we need to one more time do a docker compose. Just to be on the safe side, I'm just going to kill this docker container one more time, and then I'm going to run the docker compose again. So the container has started again. So let's check what is the count now. So you can see that the Python script is keep on inserting records into the Postgres database. So now if you want to see the logs, you can just say like docker logs and then put the container ID. Oh, I'm sorry. So docker ps. Okay, we got a new docker container, right? So docker logs and then the container ID for the Python app. So you can see that all the logs, yeah, for inserting the records. So this way you can implement the logs. If you want to see the logs in real time, then you can just use logs -f, and then you have to put the container name. So for that, docker ps and then docker logs f, and then the container name is Postgres Python app. So you can see the logs in real time. So as the script is executing, it's displaying all the logs. So this is a very useful feature if you want to check the status of your container. So with this, we have come to the end of today's session. So I'll just try to summarize what we did today. So first, we tried to create a Docker Compose file, and then inside this Docker Compose, we wrote the Docker components for Postgres database and also for the pgAdmin. So we made sure that both of these services are part of the same network, and we created a network for this, which is called as DEM, and we specified the network information as well inside the Postgres as well as inside pgAdmin. So when we launched the Docker Compose, then we had containers for Postgres and pgAdmin, and then we tried to visualize our Postgres database by means of pgAdmin. Then we wrote a simple Python script using SQL Alchemy for connecting to the database and inserting records into the table. And for this, we first tried to create an engine, and then we implemented a retry mechanism whenever we try to connect to the Postgres database. And then we used a faker library for creating some fake records for the user ID and the amount of the database table. And then we inserted the actual records into the database table. So for this script to execute indefinitely, we used the indefinite while loop. And also for inspecting the logs of the script via Docker logs, we also used logging functionality and then replaced all the print statement by means of logger. After this, we also try to write a Docker file for the Python script and then put this Docker file as part of our Docker compose and then created a Docker container for our Python script. We also made sure that the Python script also runs as part of the same network DEM. So when we are done with that, we then finally run the Docker compose, and then we made sure that this Python script is inserting records into the Postgres table indefinitely. So with this, we have come to the end of today's session. In case if you have any questions or doubts or clarifications or even feedback, please feel free to mention them in the comment section. You can also find the code components that I have used today in my GitHub repository. The link would be found in the description. So thank you once again for checking my channel, and I hope you like this video. Thank you.